This video finishes up section 1.9 from the textbook and deals with long division, which is what we need to use when we are dividing a multinomial by a second multinomial. And I have the steps listed out here as far as long division goes. And they might not make a whole lot of sense right now, but they will as we go through the process. The first step is the one that I need to make sure that we explain before we get started. And that is that we need to arrange each multinomial in descending order. So what that means is that we need highest exponent to the lowest. And the reason that this is going to be helpful is because when we go to actually start doing the division, it's going to get really complicated if we don't have them in the right order, and things aren't going to work out nicely, and it's going to get real messy and not work out to be correct. The other thing that's really important here is that if we're missing any powers of the usually variable x, we want to insert those as a 0x to whatever it is. And the reason for this, again, is just to keep things organized. When we start going through the algorithm of long division, it just is a lot easier to have a placeholder of 0 instead of having everything jam-packed together because it gets things all out of order. So the process for long division of polynomials is very similar to the process that you do with just straight numbers. The first thing you want to do is you want to divide the first term of the dividend, meaning the number under the division symbol, by the first term of the divisor, the term or the expression outside of the division symbol. And whatever that is going to be our first step on our first term of the quotient. Then we're going to multiply everything in the divisor by that term we just found, subtract the product from the original dividend, and then we can continue this process, repeating those steps over and over again until we get to the last term. So if we look at an example here, we've got 2x squared minus 5x minus 3 divided by x minus 3. And the reason that we can't just do what we did before is because we would have to split up 2x squared over x minus 3 minus 5x over x minus 3 minus 3 over x minus 3. And that's really no simpler than what we had to begin with. So we do long division instead to get a simpler answer. It's also possible to factor if you're good with factoring. Sometimes these do factor to simplify, and that helps make things a little bit easier as well. But if we look at long division, first thing we need to check is to make sure that they're in descending order, and in this case they are. We've got x squared, x, and then our constant, and this one we've got x and our constant. So we are also not missing any terms here. We've got x squared, x, they go in order all the way down. So we're going to put that 2x squared minus 5x minus 3 under our division symbol. And we're going to put our x minus 3 out front. And so this is where we get to step 3, which is to say, what do we have to multiply x by to get 2x squared? Or what is 2x squared divided by x? Well, that's 2x. And I know I'm putting it over here, but I'm doing that because this is the x column. I try to keep an x squared column, an x column, and a constant column. So we say that x squared divided by x is 2x, so that's going to be our first part of the quotient. So 2x, so this is where we say, okay, now we're going to take 2x times x is what we wanted, 2x squared. And then 2x times 3 is going to be minus 6x. So again, all we did was we took this x minus 3 and multiplied it by 2x, and we place it there. Now what we are going to do is we're going to subtract this whole expression. Some people find it easier to just go through and change the signs, and I'm doing it in a different color so that we realize that it was not the original sign. We're actually subtracting, so we're changing the sign. So then we say, okay, 2x squared minus 2x squared is 0. That's what we wanted. That's why we made that first term of the quotient 2x. And then the second term is going to be negative 5x plus 6x, which is just going to be x. Next step, we bring down the next term in the dividend. And we say, okay, what do we need to multiply x by to get x? Well, we just need a 1. 1 times x is x. So we would get x times 1 is x. X times negative 3 is negative 3. And again, if we change our signs here to subtract, x minus x is 0, negative 3 plus 3 is 0. So we're left with a remainder of 0, and our quotient is 2x plus 1. So when you divide 2x squared minus 5x minus 3 by x minus 3, we end up with 2x plus 1. And this is a case where we could have technically factored and simplified, and that would have also worked for us as well. So we are going to try another example here. I'll do a few examples with you, and then I'll have you do one on your own. So in this next example, we have a cubic function, and they are in descending order: cubed, squared, x, constant. So we're good there. And 4x minus 6 is also descending. We're not missing any terms in either of our expressions, so we can just go straight to the long division. In this case, it would be a little bit more difficult to go about factoring it because there are 4 terms, but it's possible. So we've got 20x cubed minus 54x squared plus 44x minus 12. And then we are dividing that by 4x minus 6. So the first thing we say, what do we need to multiply 4x by to get 20x cubed? Or what is 20x cubed divided by 4x? In this case, it would be 5x squared. So we're going to, again, put this in the x squared column, so we have that. And we have 5x squared times 4x is 20x cubed. Then 5x squared times negative 6 is going to be negative 30x squared. Again, we're going to go through and change the signs because we're subtracting. So 20 minus 20x cubed is 0. Negative 54 plus 30x squared is going to be negative 24x squared. Then we bring down our next term, which is 44x. And we say, what do we need to multiply 4x by now to get our negative 24x squared? In that case, we would need a negative 6x. Again, we've got our x column here. So we've got negative 6x times 4x is going to be negative 24x squared. Negative 6x times negative 6 is going to be positive 36x. And this is where we would need to be careful as far as changing our signs go. It's always easy to change a negative, but to change the positives a little bit more tricky if you don't have different colors. So negative 24 plus 24 is going to be 0. 44 minus 36 is going to give us an 8x. Finally, we bring down our negative 12, and we say, what do we need to multiply 4x by to get 8x? Well, we need a 2. So 2 times 4x is 8x, and 2 times negative 6 is negative 12, and we see that we have 8x minus 12 minus 8x minus 12. And so if we change our signs there again, we end up with 0, because we got 8 minus 8 and negative 12 minus negative 12. So we end up with 0. So we have no remainder again, which is nice. There are some cases where we will have a remainder. And so in this case, our quotient is 5x squared minus 6x plus 2. So like I said, this one does actually factor. It's just a little bit more difficult to see right off the bat. I'm going to do one more example here with you because this one is missing some terms as far as the descending order goes, and I want to show you an example of that. In this case, we have an x to the 6th, but we're missing an x to the 5th. Then we've got x to the 4th cubed squared, but we're missing an x. And then we've got a 1. So in this case, when we write this, we're going to write it as x to the 6th plus 0x to the 5th, or you can just leave a blank spot, plus x to the 4th minus x cubed plus x squared. And then we need that plus 0x and plus 1. So now we have 6, 5, 4, 3, 2, 1, and constant. As far as the divisor goes, x cubed, x constant, we're okay. So x squared plus x plus 1. And now we need to say, okay, what do we multiply x squared by to get x to the 6th. Well, that's not too bad. We just have to multiply by x to the 4th. So we actually skip over to the 3rd column here, our x to the 4th column, to write that up there. So we get x to the 4th times x squared is x to the 6th. X to the 4th times x is x to the 5th. And now you can see why we need that placeholder, because otherwise we would have an x to the 4th over x to the 5th, and it would just be a mess. Because in this 3rd term, x to the 4th times 1 is x to the 4th, and then everything would be all out of line, and you have to pay really close attention. So again, we're going to change our signs because we're going to subtract. X to the 6th minus x to the 6th is 0. 0 minus 1 is going to be negative x to the 5th, and 1 minus 1 is going to be 0. So I'm again going to write it as 0x to the 4th in this case because it is a placeholder. Then we will bring down the x cubed. So now we say, what do we multiply x squared by to get negative x to the 5th? We get negative x cubed. So negative x cubed times x squared is going to be negative x to the 5th, which is what we wanted. Negative x cubed times x is going to be negative x to the 4th. And negative x cubed times 1 is going to be negative x cubed. Again, we are going to switch our signs, which in this case ends up being all positive. And we get negative x to the 5th plus x to the 5th is 0. 0 plus 1 is going to be x to the 4th. And negative x cubed plus x cubed is going to be our 0x cubed. And again, like I said, we like to write that because it gives us our placeholder in the middle here. I want you to pause the video now, complete this cycle all the way out, and then resume the video to see if you got the right answer. So if you completed all of the steps for this, you should have ended up with x to the 4th minus x cubed plus x squared minus x and plus 1. And again, each step you just keep bringing down the next term and making sure that you subtract to keep track of all your signs. So this might be a good time to pause it if you didn't get the example correct and see where it is that you might have made a mistake. So we're going to do one last example here, and that is x to the 4th plus 4, and we're dividing that by x squared minus 2x plus 1. Now, in this case, again, we're missing some terms to start off with. We're missing an x cubed, an x squared, and an x here. So when we put the dividend underneath the division symbol, we end up with x to the 4th plus 0x cubed plus 0x squared plus 0x, because all of those are missing, plus 4. And then out here we have our x squared minus 2x plus 1. So then we say we've got x squared. What do we need to multiply to get x to the 4th? Well, we need an x squared, and again, that goes in our x squared column. So x squared times x squared is x to the 4th. X squared times negative 2x is negative 2x cubed. And x squared times 1 is plus x squared. So if we go through and do our subtraction by changing our signs here, x to the 4th minus x to the 4th is 0. 0 plus 2 is going to be 2x cubed, and 0 minus 1 is going to be minus x squared. We're going to bring down our 0x, and we're going to repeat the process again. So again, at this point, pause the video and work the rest of this problem through. You will end up with a remainder, so don't think you've done something wrong if you end up with a remainder. So try that out and then resume the video to see if you've gotten it correct. So if you went through and worked this problem, the next term you would need would be a 2x. So 2x cubed, and then times the negative 2 would be negative 4x squared, and then the last would be a 2x. Again, we're going to change all of our signs, and we end up with 0. Negative 1 plus 4 is going to be negative 3x squared, and 0 minus 2 is going to be negative 2x. Last thing we do is bring down the plus 4, and we say we need a negative 3 to get a negative 3x squared, so we get negative 3x squared, positive 6x, and minus 3. So if we do our last step here, change all of our signs, then we end up with negative 3x plus 3x squared is 0, negative 2x minus 6x is negative 8x, and 4 plus 3 is 7. Now we're done here because there's nothing else to bring down for one thing, and the other thing is that this x is a lesser degree than the x squared. So we always want to have an expression down here that has a lesser exponent than the divisor did to begin with. So in this case, we would just write it as a remainder, negative 8x plus 7. And that's perfectly fine. Sometimes we end up with remainders. Another way that you could write this is as x squared plus 2x minus 3 plus, you would leave it as negative 8x plus 7 over our original divisor, x squared minus 2x plus 1. So sometimes we do end up with remainders, and that's perfectly fine. Not everything divides out nicely. But these are two different ways that you could write the answer to this, either as the polynomial and then the remainder. Make sure you put that r there to distinguish that it is the remainder, or you can write it as the polynomial plus the remainder over the original divisor. Either one is acceptable. So this is the conclusion for the video for 1.9. Now you should go do the homework for this section and then do the quiz for chapter 1.